Hey, welcome back to week 2. Today we're going to do something that if you're in pre-AP math, then you may have already done this in 8th grade, but a lot of people either did it and didn't understand it, or it's just been a while and you definitely need a refresher. So we're going to talk about something called radicals. Now, there are some teachers out there, you may not have actually heard the word radical because some teachers might have just called them square roots. And the thing is, I'm calling it a radical because you're going to see the symbol, first of all, is something like this. That would be a square root, but there are also cubed roots and fourth roots, fifth roots, sixth. There can be any number out here, and it's significant. Now, this year you will primarily use square roots, and that's why the lesson is about square roots. But the idea is that this is going to relate to everything, almost everything that has to do with triangles, which is almost half of your year in geometry is triangles. So you're going to be doing this, what we're about to do today, on almost a daily basis next year. Okay, so first, to understand a radical, we've got to know what a perfect square is, because what a radical does is the opposite of squaring a number. And squaring a number looked like this. Like that's a 1 squared, but remember it just meant 1 times itself. So 1 times 1 is 1. 2 squared, you're just going to take whatever number's here and multiply it by itself as many times as that exponent says. So this is saying multiply 2 by itself 2 times, multiply 3 by itself 2 times, so on and so forth. So this is not necessarily new to anybody. And you can make your chart really as far as you want. I'm running out of room, but you know, if you want to hit pause and go all the way out to like 12, that would be awesome. Okay, so what a square root is it's undoing the squaring of something. Undo a square. So what we just did here, we're going to work backwards. And what that means is that the numbers that we got over here in this list, like the numbers that these things were equal to, okay, that's going to be the number that's underneath the square root. And, you know, it is called a square root, just so everybody knows. This is a square root. It's also called a radical. Some teachers that I get mad at say, oh, put a roof over it. And that's so unprofessional. It's not a roof. It's a square root. So, for instance, if we have like the square root of 36, this just means that what you're asking yourself is, okay, what number times itself is equal to 36? Okay, well, the answer to that would be 6. So that's what you're looking to do, is just that's what you need to be thinking in your head, and then that's the answer that you would write. And so whenever you're undoing a square root, it's pretty easy. So the square root of 100, what number times itself is 100? Well, 10 times 10 is 100. And just so you have it, now this assignment's not going to be a lot about it, but if I had a little 3 there, and then like let's say I had the number 27, what this is saying is it's undoing, instead of just saying like a number times a number is 27, this is saying a number times the same number times the same number, okay, is equal to 27. And they all have to be the same number. So since there's a 3 here, it's how many times you have to multiply that thing by itself. So it's not 2 times 2 times 2, because I think that's 8, but 3 times 3 times 3 should work, okay? So that's just in case you see it, but most of the time you're going to see square roots. Okay, so now what do we do if there's a number under there that is not a perfect square? Meaning that, you know, the number underneath, like in this one, the square root of 50, well, that's not, you know, 6 times 6 or 7 times 7 or 8 times 8. It's close to 7 times 7. But it's not exact. So what you're going to do, I've seen this taught many different ways. I'm going to show you, like, I really think this is the best way to do it, okay? What you want to do is find a perfect square that goes into the number given. And then it's going to be a simplify or reduce. Simplify, reduce. And so it doesn't make much sense when it's written over here. I get that. But like we're going to do it with 50 and hopefully this will be the way to do it. You may have been shown some sort of weird factor tree thing. I don't like that. It's a lot of work. It's not very fast. This way I'm about to show you makes way more sense to me. Okay, so 50. All right, what you want to do is look down your list of numbers from up here that we wrote down. You're looking at your perfect squares because that's what these are called. Look for which of these goes into 50, and you preferably want to find the largest one that goes into 50. So I'm looking at 25, and what I'm going to do is break up 50 into 25 times 2 because 25 times 2 does equal 50. Now they're both under a radical, okay? So you still need to recopy that radical on top of both of these. And then that's step 1, find a perfect square that goes into the given number. And then step 2 is to simplify or reduce. And so what does that mean? Well, what that means is, do you know the square root of 25? Yes, you do. It is a 5. Do you know the square root of 2? Well, I don't. You probably don't either. It's going to be a funky decimal. We don't want that funky decimal. If it's not something that you can break down, you just recopy it. And that whole thing is the simplified version of the square root of 50. Okay, so let's try another one, square root of 48. So we want to look down our list of numbers and find things that go into it. Now, I know 4 goes into that number, but see if there's a larger number on your list that goes into 48. And I think if you look down your list, you're going to see that 16 is on the list, and it does go into 48 3 times. And maybe that's not as quick for you, but feel free to grab a calculator to do your division and actually type in like 48 divided by 4, 48 divided by 9, 48 divided by 16 until you find one that goes into it. So that's our step 1, and I wrote it all underneath one radical. If you want to break it up into the 2, then that's absolutely fine. And what is the square root of 16? It's 4. What is the square root of 3? IDK. So I recopy square root of 3. All right, cool. So now let's try 200. It's a little bit bigger number, but that's okay. Square root of 200. All right, so if you look down your list, if you actually did what I asked and hit pause and worked out your list all the way to 12, then you would see one of your perfect squares is the number 100, right? And 100 times 2 is 200, so we're breaking it down. Now, what is the square root of 100? Well, that would be 10. 10 times 10 is 100. What's the square root of 2? I don't know, so I recopy it. Okay, so the next box is going to lead you into what you're going to look for in geometry to let you know, oh, I'm supposed to be doing that radical thingy. Okay, well, here's how you're going to know. If you're in the middle of a problem and you look at something like that and they tell you to solve, or you're supposed to be solving and getting the x by itself, then you'd probably start off like with your algebra and you'd move the 5 to the other side. That's 41 minus 5, I think that's 36. And then once you have that, then the question becomes, oh, okay, so now what am I supposed to do here? Well, what you're supposed to do here is figure out what number squared is equal to 36. And another way of doing that or writing that is to actually write the square root over both of them. And that cuts this down to a normal x, and the square root of 36 is 6, okay? Over here, same thing. X squared is 75, so put them both under a square root thing. And so x is the square root of 75. That doesn't have a pretty answer. That's your clue to do what we just did above. See if you can break it down. I'm thinking that's the square root of 25 times 3. And what's the square root of 25? 5. What's the square root of 3? IDK. All right, cool. So that is pretty much your lesson. I know this is like super quick. The only other thing I have to show you is like, let's say somebody wanted you to do like 2 root 6 and then minus 3 root 24. Okay, if you're supposed to put these together, like add or subtract, then you cannot do it unless these match. And so some people are like, oh, I can't do it, they don't match. But let me tell you, sometimes you can make them match. For instance, if you break this down, just like we did a second ago, the square root of 24 could be the square root of 4 times the square root of 6, right? And then the square root of 4 is 2. The square root of 6 is the square root of 6. And see how there's that 3 chilling in the front? Just bring that 3 back now and put it with the 2 that's out here. So this whole thing just becomes recopy the first one, minus, instead of 3 root 24, it'll be 3 times this, which means 3 times 2 is 6. So it'll be 6 root 6. That 3 only goes with the coefficient. It does not go with what's underneath the radical, okay? And now what do? Well, now what you do is you just do the coefficients in the front. So 2 minus 6 is negative 4, and then the root 6 you just recopy. So that is the answer for that problem right there. So good luck doing the homework. I hope it's pretty easy for you. You want to be good at these. It's going to show up, like I said, daily. All right, we'll see ya.